Shouldn't be negative. 4x squared. Why did you, oh, yeah, why did you get a negative? Do you have an answer? I'm gonna have you shout it out. What did you get? Anyone else get that? Okay, cool. Okay, next one, erase. Okay, so that's okay. We half and half, so just maybe in a little area. Do you think it's plus or is it minus? Okay, still plus 3x? Okay, okay, so a few of us made one little error maybe in your algebra, but that's okay. Next one, because I was rushing you. I need you to double time it. Do it. What I want you to see is how Pascal's triangle is created. What you do is there's always ones on the diagonal and it creates a triangle. So 1, and then this would be my next thing, right? 1 and 1. Ones go on the diagonal. Now you put your ones on your diagonal, and then you add the 2 above to get the 1 right directly below. What's 1 plus 1? 2. We put ones on my diagonal, then you add the ones above it. 1 plus 2 is 3, 2 plus 1 is 3. You see how this is working, creating a triangle. We put a 1s on our diagonal, we add 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and we have our 1s. This continues forever, so we can go to any degree here. So if I get to a bigger degree, you're not going to want to multiply it out by hand. And there's many of you that will get this on the ACT because they want to see if you can do Pascal's triangle. Because if you try to do this on the x minus 3 to the 6 on the ACT, you wasted 5 minutes. And that's a lot of your test. You get what I'm saying? It might even take you longer than that. Okay. So let's create Pascal's triangle. Grab a blank paper. Hurry, grab one. They're on your desk. So let's create Pascal's triangle here. So if you understand how to create it, make it very organized, but kind of write small. So I'm going to create many rows, and then you can use it the rest of the time. But what you're going to want to do is be able to create it on the test. So understand how it works. So you put your 1 at the top, then 1s go on the diagonal. So then 1, you add up, 2, 1. So everybody should be doing this on their own. I want you to create lots and lots and lots of rows. Keep going. So it says up to the 6th row. Oh, crap. Here's one more thing I wanted to say. Sorry, I'm feeling rushed. What you have to remember is this is degree 0. Does everybody understand? It's row 1, but it's not degree 1. It's degree 0. Then this is degree 1, degree 2, degree 3, degree 4. So I kind of write myself a little note. This is degree 0, degree 1, degree 2. So I can just quickly look. Degree 3, degree 4. Does everybody see? You always have to start with 0, though. That's what people forget. Okay, continuing Pascal's triangle. You should be doing it on your own. And then if you need help on how to fill it in, you can check up here to make sure you're going in the right direction, but make sure you're practicing it on your own. Okay, I'm going to just stop there, and if I need to go for, actually, if you can keep going for a second. Are you guys further than this? Yeah. Okay, awesome. So let's just stop then, and if we need to go further, we can. We can always keep going. Let's just stop there for a second. So then I'm going to write myself a note so I can easily go back. Degree 0, degree 1, degree 2, 3. I put little dots to make sure I understand that's not part of the triangle. Degree 4. This will be my coefficients for degree 5, degree 6, degree 7. And if we need to go further, we can. Okay, here we go. So now let's use Pascal's triangle. I'm going to show you how this works because there is a little bit more to consider here. So everybody, this is a binomial raised to the 4th degree. Yeah, we can do it by hand, or we can use Pascal's triangle and get through it way quicker. So what are the coefficients of 4, degree 4? So everybody locate degree 4, it would be this. So that's the first thing you write out. So you would say 1, 4, 6, was it 4, 1? 4, 1. Okay, awesome. Those are the coefficients, the number in front of the variable for now. Now, this is what I call my front thing, and this is what I call my back thing. So what you do next is you take the front thing, no matter what it is, and raise it to the highest degree, and then count your way down. So this will be the front thing to the highest degree, and then just count down. X to the fourth, X to the, and you're going to want to do this on white paper for sure. Every problem, they're long. X2, 3, 2, X1, X0. Does everybody see how I know I ended in the right spot since I started at 4 and ended at 0, and I ended with a coefficient? Then my next one, you're going to do it backwards with the back. So you're going to start with the lowest degree and go up to the highest, which is of our, this one is 4. So you'll do the back thing, 2 to the 0, 2 to the 1, 2, 2, 2 to the third, 2 to the fourth. So you do it backwards. Now here's what you can check to make sure you've done it right. All of your degrees before you simplify should add up to be that degree. So it's degree 4. 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 0 plus 4 is 4. So we're all good. Now we can simplify. All those degrees should add up to be 4. Do you see how they add up to be 4? Because it's degree 4. So now what we're going to do is we literally just simplify it from here. Multiply out this. 1 times x to the fourth times 2 to the 0. What's 2 to the 0? 1. 1 times 1 is 1. 1 times x to the fourth is x to the fourth. I just found my first term. You just multiply it out in sections. So let's multiply out this section. 4 times x cubed times 2. What's 4? Let's multiply out the coefficients. 2 to the first. 4 times 2 to the first. 8. Isn't it positive 8? Okay. Positive 8, and then we have times x cubed. Does everybody see it? I just found my second coefficient. I mean my second thing, second term. We're just multiplying this out. So here we go. 6 times x squared times 2 to the second. I'm going to multiply the numbers. 6 times 2 to the second, well, isn't that 4? 4 times 6 is? So plus 24, and then we have our x squared. Okay, cool. We just found our third. 4 times 2 to the third. Well, 2 to the third is 8. 8 times 4 is? Plus 32, and then we have our x to the first. So x to the first, and then we just figured out that. And then 1 times x to the 0, which is 1, times 2 to the fourth. 2 to the fourth is 16, so plus 16. Does everybody see how that's positive 16? And we just multiplied it out way quicker. Well, we went kind of slow because I was teaching you. Does everybody see how that worked? Now, next thing to notice is it should be in standard form for you. So you should have your highest degree to lowest degree. So look, it's degree 4, so we start with 4, 3, 2, 1, and constant. So it's in standard form for us. So that's how I know I've done it right. If it jumps around, you've unaccidentally done something wrong. One more, another one, and then you'll try one by yourself. Here we go. Okay, let's do a plus 2 to the 7th. This one would be a nightmare. Now, I don't care if you just want to watch. You don't even have to actually do this one because, like, you're not, I mean, I'm not even going to assign all the homework. Like, I'm just going to give you, like, you can practice what you want. So everybody, tell me the coefficient. You got to go to degree 7. So go back to your Pascal's triangle. Degree 7. Whoa, you've got to have a... Okay, you're going to read them to me, and I'm going to spread it out. So you can just watch if you want on this one. So you said, oh, guys. Okay, sorry. Yikes. Okay, perfect. Now I take my front thing, I kind of spread it out a little bit unevenly, and I start with my highest degree counting down. So my front thing is a, so a to the 7, 6, 5, 4, 3, 2, 1, and 0 ended in the right spot. Everybody see how this works? And I'm going to go the back thing, the opposite, 0 to the highest. So 2, 0, 2, 1, 2, 2, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh. What in the sound? So then, what in the sound? Okay, so then from there you'll simplify it in sections. So multiply this out. 2 to the 0 is 1. 1 times 1 is 1. A to the 7th times 1 is a to the 7th. Ready? Next one, 7 times 2 to the first, which is 7 times 2, which is 14, plus 14, a to the 6. Okay, cool. And then 21 times 4. Somebody, hurry, hurry. 21 times 4, because 2 squared is 4. Plus 84, and then that's a to the 5th. Cool. 35 times 8, because 2 to the 3rd is 8. 35 times 8. 280? plus 280, and then that's a to the fourth, cool. And then we have 35 times 16, because 2 to the fourth is 16, or you could literally type in 35 times 2 to the fourth. What? Plus 5, 60, a to the third, okay, cool. 21 times 2 to the fifth, go. So plus 672, a to the second, awesome. 7 times 2 to the sixth, go. Plus 4, 48, a to the first, which is a. 1 times 1, and then times 2 to the seventh. What's 2 to the seventh? And I'm done. I just multiplied out an a plus 2 to the seventh in a seventh of the time. Isn't that cool? Isn't that cool, guys? It is way cool. Okay, so can you guys do one by yourself? Okay, do this one. Do number 3. Go for it. On your paper. This is fun. Let's do one with negatives. You can just watch if you want. It's all about how you want to learn. So degree 3, tell me the coefficients. Okay, perfect. You take your front thing, which is n, and you raise it to the highest degree to lowest. Then you take your back thing. Now there's a negative, so we're going to have to take the negative with it. So you're going to have to use parentheses. Negative 3 to the 0, negative 3 to the first, negative 3 to the second, and then negative 3 to the third. Now you're going to have to be very careful because any negative raised to an even power is going to be positive. You've got to be careful. So right here I have 1 times n cubed, which is n cubed. Now does everybody agree? Look at this next one. Negative 3 to the first. Isn't that negative 3? Negative 3 times 3 is negative 9. So I'll have minus 9n squared. Now look right here. I've got to be so careful because negative 3 squared is positive 9. Positive 9 times positive 3 is positive 27. And then we have our n as well. Everybody see what I did? And then look, negative 3 to the third power is negative 27. Negative 27 times 1 is negative 27 times 1 is negative 27. So now notice, this is bouncing between positive, negative, which, think about it, guys, isn't every other degree going to be even? You see what I'm saying? So that's going to make sense. If you have negatives, you should either have you should have it bouncing. Does that make sense? Because of the degrees. If you have 2 negatives, you've messed up on a sign in a row. All good? Okay. Let's do another one that's a lot more simplification, and then I'm going to just let you go for it, and I'm going to not even assign all of them. It's just all for your practice. So just watch this one. You know what I mean? Like I'm not even going to assign homework, so just stick with me, guys. So there's just a lot more simplification involved in this one. So quickly tell me, it's the same steps though. Quickly tell me the coefficients on this one. Perfect. Okay. Then I take my front thing. I've got to use parentheses. Honors kids, my honors kids already took this test. So many just messed up because they didn't put parentheses. There's a 3 and an m in front. So we have to do both 3 and m to the 5th, both 3 and m to the 4th, and so on. And then look. So watch in a second, watch what happens. Okay, let's do the next one. The back thing is 0. Good catch. Good catch. So now our back thing is negative 2n. So we have to do both negative 2 and n. Okay. All right, here we go. Now simplifying this is where people royally screw it up. So let's be very clear on something. You have a 1, you have a 3 to the 5th. You also have negative 2 to the 0. Does everybody see that? Did you all hear that? Okay, so that obviously becomes 1. So you have 3 to the 5th. Hurry, type it in for me, 3 to the 5th. 243, and then we had times 1. So 243 m to the 5th. Okay, now watch out, because on this one, people mess it up. We have a 5, so everybody get your calculator type 5. We also have 3 to the 4th. So 5 times 3 to the 4th times negative 2. Eight, 10, and then we have our m to the 4th, okay? Now here, be very careful. You have, oh, and an n, right? Good catch. So since I put m in front, I'm going to stay consistent. I'm going to put m in front on the rest. 10 times 3 to the 3rd times negative 2 in parentheses squared. Or think to yourself, I don't even need to type in the negative because a negative squared is going to be positive. So go. 10 times 3 to the 3rd times negative 2 to the 2nd. What is it? 1,000, and it's positive, right? Now we have an m to the 3rd, and we have an n squared. Okay, cool. 10 times 3 to the 2nd, so that's 10 times 9 times negative 8, notice, because negative 2 to the 3rd is negative 8. So I'm seeing it in my head. What do we get? Negative 720, then we have m squared, and then we have our n cubed, okay? And then 5 times 3 times negative 2 to the 4th, this one's going to be positive because it's an even degree. 5 times 3 times 2 to the 4th. Plus 240, and then we have our m and then n to the 4th. And our last, we're almost there, yay. 1, negative 2 to the 5th times 1. So it's going to be negative. Negative 96, and then we have our n to the 5th. And we're done. Way quicker than doing it by hand, though. That is still by hand, but by distribution. Yeah, by distribution. All good? All good. Can you guys do a hard one now? All the hard ones. Okay, what I want you to do is do any problems you want in 1 through 20. Do not pick the easy ones. Pick the hard ones. That's why we're practicing. I won't assign homework. If you'll just do a couple hard ones in class and check them off with me. You're going to need major paper, so grab extra blank paper and ready, set, go. This is more what you would see on an ACT. In fact, they would not put one where they made you expand all of it. They would do this, however. They would say, find the third term in the expansion of this. So it says expand it, what's the third term in? Still doing this by hand would be, you would fail your ACT because you'd spend the whole ACT on that one problem. So we would use Pascal's triangle. Does anybody have up to degree 12? Anyone? No one? Okay, let's hurry and get there real quick. So guys, if we need the third term in, I'm not going to write out all of this. I'm not going to figure it all out. I'm only going to go up to the third term here and stop. So what are the coefficients for x12? You just got at the bottom. Oh, it wasn't? Still no? Oh my gosh, wait, no way. Oh yeah. Dude, how do you have to find that? So we've got the coefficients for the degree 12. So I'm only going to list out, we have 1, 12, 66, and then obviously it continues, but why list out more? Does everybody see why? Because this is where I'm really essentially stopping. Does everybody get what I'm doing? So I want the third term in. First term, second term, third term. Do you get it? Yes. So then look how easy this is. This will be x12, x11, x10. Okay, cool. And then the back thing will be 3, 0, 3, 1, 3 squared, right? So do you see how I'm only going to answer this, the third term in? I don't have to do it all out. 66 times 9 for me. 594 x10. That would be your answer. So if it only asked you for the fifth term in, I would have had to go 2 more terms. Does everybody see how easy that is, though? Cool. Okay.